Tensile test on mild steel. So the objective for this experiment is to study the mechanical properties of mild steel specimen under the tension load. There are few apparatus that we have used. Firstly, universal testing machine, then dial indicators, extensometer, scale and also vernier calipers. Step 1. Measure the initial diameter of the tension test sample in two perpendicular directions using vernier calipers. Average initial diameter D we have got is 12.62 mm. Step 2. Measure the length of the specimen between the grips using a scale. Length of the specimen between the grips is 194 mm. Step 3. Punch marks are made at a distance of 2.5 D. Step 4. Insert the specimen into its position and mount extensometer on the specimen. Step 5. Readings on the dials A and B of extensometer are adjusted to 0. Least count of extensometer 0.01 mm. Step 6. Experiment is conducted. Load extensometer readings are read at regular intervals of load up to the yield point. Ivory scale readings are noted till the experiment failure. So now push the green button. So now press the red button. Step 7. Graph. Load West ivory scale readings. Step 8. Graph. Load West extensometer reading. Extensometer reading in DIV, load in KN.
The x is 4.2, the y is 9 and the slope is 2.14.
Step 9. Join two pieces of the text sample and measure the diameter at the neck of the specimen.
The final diameter is 8.46 mm.
Step 10. Measure the final length between three punch marks.
The final length between the punch mark is 86 mm.
Step 11. Observation and calculations. There are 5 calculations that we have to do, which is yield stress, tensile strength, modulus of elasticity, percentage of elongation, and lastly percentage reduction in area. For the first calculation, the formula is yield point over original area, which is 41,000 divided by 122.07, which we will get 335.87 Newton over millimeter square. And for the second one, tensile strength, which the formula is ultimate load divided by original area, which is 57,000 divided by 122.07, we will get 466.95 Newton over millimeter square. For the third one, modulus of elasticity, the formula is slope times 1 over least count times gauge length over original area, which is 2.14 times 1 over 0.01 times 120 over 122.07, which the answer is 210.37 GPa. And for the percentage elongation, the formula is final length minus punch mark times 2 divided by punch mark times 2 overall times 100, which the percentage we get is 37.38%. And for the last is percentage reduction in area, which the formula is original area minus final area divided by original area and overall times 100, which is it 122.07 minus 56.18 divided by 122.07 times 100, which the percentage is 53.98%. So that's the answer, and that's the calculation that we do, and the answer is right here. So now we are gonna check it.
The conclusion is mild steel is commonly used in engineering applications that demand high tensile strength. This is due to mild steel crystalline structure, which allow it to bear large axial loads before fracture. Aluminium, on the other hand, has a wide range of applications in design that call for low-density materials, such as aerodynamics and various motor vehicles. When compared to mild steel, aluminium has a higher ductility rate and hence has lower Young modulus level values, which influence structural component deflections. As a result, this experiment yields a near match between tensile strength and theoretical data.